Hello everyone. In this presentation, I will present to you our paper, Quality of Goods and Price Setting. As we know, answering the questions, how do sellers set the price, is very important. Existing literature created a very sturdy foundation in this area. For example, Kleno and Krivtsov 2008 and Nakamura and Station 2008, they found significant evidence of price rigidity in conventional markets. And some potential sources of the price stickiness are search cost, cost of nominal price adjustment, transportation and delivery cost, and managerial cost. This price friction makes seller cannot change their price immediately and cause price becomes sticky. And nowadays, with the increasing in the availability of data in online markets, provided the opportunity for research using online price. And in this special market, we know that the search cost is very small because searching online is easy, and seller can change the price easily just by a few clicks, so the cost of nominal price adjustment in online market is also insignificant. The transportation and delivery cost also small and doesn't depend on the location of buyer. So we expect to see the price in online market as flexible. And yes, indeed, Gronichenko, Semirov, and Talamera 2018 found evidence that prices are more flexible in online market than in conventional market. However, this difference is quantitative rather than qualitative. What is new in our papers? In this research, we introduce quality of products into price setting. We do that because we find lack of precise quality measures in previous works. Also, quality is often omitted in rigidity models due to the difficulties in quality measures. Meanwhile, in the supply side, producer and seller, they pay more to advertise new generations and high-quality products. In buyer side, such effort is likely to be larger for high-quality products. Therefore, we expect to see the difference in price setting behavior for products depending on the quality of product. Existing research attempt to measure the quality of products in order to construct the quality adjustment in product replacement in CPI or address the quality bias in price index. For example, the works of Shirasuka 1999, Boone 2018, Escobar 2019, in which Boone and Escobar papers close to our work. They construct the price index for microprocessor and smartphone respectively, and they found quality measures have a large impact on price index. However, this impact may be different depends on the countries or the period. For example, Bills 2009 finds that two-thirds of the price increase in the US should be treated as quality increases. Meanwhile, Krivtsov 2016 find that less than one-third of the price increases in Canada should be attributed to quality growth, and therefore quality bias is not an important source of potential mismeasurement of CPI inflation in Canada. In order to have a clearer picture on the impact of quality changes on price index is not easy, because the difficulties in quality measure. For example, the case of Bordeaux wine in Cambridge, 1997. He finds that the imprecise quality measure can lead to a misleading result. For example, the quality of products doesn't have any impact on the price. What we do in this study? In this study, we investigate the impact of quality on price setting behavior and also the impact of new product release on price setting. In addition, we construct our own quality index and quality adjusted price index. We use nearly 4 years of data collected online, including multiple sellers, and we have unique manufacturing product number for each product and exact quality measure for each product. In this study, we use online prices data collected from a leading price comparison website from April 2009 to December 2012. Our data is at product, seller, month level in monthly frequency. We have more than 200 sellers, more than 800 CPUs. In total, we have more than 110,000 observations amended with performance score for each CPU. In this study, we have two approaches to introduce quality into price setting measure. The first is quality adjusted price, which is the price per unit of performance. Second, the quality weighted for price setting measures, for example, frequency and size of sales and frequency and size of price change. Here is the dynamics of CPU prices. In these figures, the dashed line is the AMD CPU and the solid line is the Intel CPU prices. We can see in general AMD CPU are often cheaper than Intel CPUs in both actual price and quality adjusted prices. In addition, the blue and red lines are the new generation of CPUs. We can see that the actual price of the new generation is quite similar to the price level of the Core 2, which is the oldest generation of CPU. However, the quality adjusted price of this new generation are much lower than the old generation, which means that the price of old model does not fall enough to equilibrate to the price performance ratio of the new model, and this result is consistent with Ice-Gobert and Byrne and Sichel 2019, and also is implied that actual prices may reflect incorrectly the expensiveness of product. Here is the price distribution of CPU prices in our data. So we have 814 CPUs after we drop 1% cheapest and 1% most expensive CPUs in our data. So we have the 5% cheapest CPUs in our data have the price smaller than $53, and the 5% most expensive has a price higher than 1,100. And in general, the high quality products have higher prices than low quality products. As we can see, the performance weighted here increase all the quartile prices. And also, the technology innovation could decrease the price per unit of performance, but this impact is dominated by the expensive quality premium of high-class CPUs. Therefore, the price per unit of performance is higher for high-quality products in general. Existing literature shows that lots of price changes last only for a limited period of time, and if we exclude these temporary price change, the median frequencies is roughly half of what it is including these temporary price changes. There is an ongoing argument about the impact of this temporary price change. For example, Cahill and Mead-Regan 2015 argue that sales do not affect monetary non-neutrality. However, Semirov 2019 suggests that sales may interact with regular prices, or Anderson 2017 argue that sales are parts of sticky plans. Therefore, in this paper, we reported both posted prices and regular prices. Here is the frequency and size of sales in our data. We're determining a temporary price change or sales with the V shape in the price changes, follows the existing literature. Our monthly frequency and size of sales is reported below. The mean frequencies of sales is 1.8 and the median size of sales is 2.28. When we applied the performance weighted, the frequencies increase and the size decrease, which suggests that high-quality products often have higher frequencies of sales with a smaller size. We have the similar result for CPU price change. When we applied the performance weighted, we can see that the frequencies of price change increase and the size of price change decrease for both posted price and regular price. Our median frequencies of price change is around 40%, which imply that the price change every roughly 2 months. And here is the frequency and size of CPU's price changes over time. On the left-hand side, we have the whole sample, and the figures on the right-hand side is restricted for the old generation only. In general, we can see the frequency and size of negative price changes are larger than the frequency and size of positive price change, which implies the deflation in this market. For whole sample, we don't see any significant impact of technological change or release of new generation. However, on the right-hand side, we can see that the old generation is strongly affected by the release of new generation. Particularly, we can see the decrease in the frequencies of positive price change and the increase in both frequency and size of negative price changes. Next, we run the regression on the price stickiness measure to see the impact of quality of products on these measure. We control for the number of sellers, median price, percentage of price that end at 95 to 99 cents, the stability of sellers that offering the product I on 1 quarter base, the brand, and we run at the product level and we control for time fixed effect. And here is the result, which is in line with our expectation. We find that high quality products has the more flexible price than low quality products. In particular, is high frequencies of price change and smaller size. And the frequencies of positive price change of high quality product is smaller than the low quality products, and frequency of negative price change are higher for high quality products, which suggests that high quality products will decrease price more than low quality products. In order to investigate the impact of technological change on price stickiness measure, we also introduce the number of CPUs enter and exit the market with a higher performance or lower performance than the existing product. And then we introduced upgrading and downgrading into the model, which are the changes in the position of products in quality distribution in a month. We find that the number of CPUs enter can increase the frequencies of price change, but do not have any significant impact on the size of price changes. Meanwhile, the number of CPUs exit only have a positive impact on the size of price changes. With the innovation in technology, we expect to see the high quality product enter the market, and then the low quality product exit the market, and this can lead to the downgrading of existing product, which is existing product would fall to a lower quality quartile. And we find that this technological change may increase the frequency of price change for both positive and negative price changes, and also increase the size of price change. However, if the number of low quality products enter the market is high enough, it can decrease the frequency of price change, or in particular the frequency of positive price change. And how about the price conversions for high quality goods? Here we construct several measures for the price dispersion across seller. And we can see that when we apply the performance weighted, all the results decrease, which imply that high quality products would have a smaller price dispersion, and the results still stay the same after we control for seller fixed effect. We can see the result in column 7. The price dispersion decreased from 21.49 to 13.84 after we apply the performance weighted. And additionally, the seller fixed effects only account for 11% to 16% of price dispersion across seller depending on weight, which means that around more than 80% of price dispersion across seller cannot explain by delivery return or seller reputation or seller customer relationship. And here is the price dispersion since product information. We can see that over CPU lifetime, the price dispersion increase. In particular, for the first 20 weeks since product introduction, the price dispersion quite stable, but after that, the price dispersion increased rapidly. And this result is similar for both AMD CPUs and Intel CPUs. Additionally, we find evidence of spatial price dispersion in our data, which is surprising because searching online is easy and consumer can learn seller pricing behavior over time easily in online market. However, sellers still consistently set the price higher or lower than others. In order to investigate the impact of quality of products on price dispersion measure, we run the regression on the measure of price dispersion at product level. We control for the frequency and size of regular price change and other market fundamental factor, and also we control for time fixed effect. And we find that increase in quality of products would decrease the price dispersion level, and the frequencies and size of regular price change both have a positive impact on the level of price dispersion, and the results stay the same even after we control for net seller fixed effect. Next, we construct our quality index. In this study, we employ the hedonic regression similarly to which in Byrne's 2018 paper, but that rather than only control for the quality of products, we also including other market fundamental factors in order to have a more reliable result. In particular, we control for the quality of products, the median price of products, share price point, and brand. Also, we include the seller fixed effect and time fixed effect. And the coefficient beta 1 of the dummy variable D2 will be the growth rate in quality of product. Our result shows a positive change every year in quality of product in the market. Particularly, the rate is 12.1, 15.7, and 15.9 respectively from 2009 to 2012. Next, we construct our quality adjusted price index. Similar to the quality index setting, we control for the performance score of product and other market fundamental factor. We replace the performance score by the median price across seller of product I at time t, and the coefficient beta 1 of the dummy variable d2 will be the growth rate in price of product in the market. And we find deflation in CPU markets in US in this period, particularly the price decreased around 12.3% in 2010 to 2011 and 6.1% decrease in 2011 to 2012. However, the price doesn't have any significant change in 2009 to 2010, which is expectable because in this period we don't have any new generation of CPUs released. To conclude, first, we find that high-quality products would have more flexible price, which means that high-quality product would have higher frequency of price change with smaller size. Also, the price dispersion level of high-quality products would lower than the low-quality product. And market fundamentals are important factors to explain the price stickiness and price dispersion in the market. Secondly, the launches of new products could increase the frequencies, and exit of old products could increase the size of price adjustments of existing products in the market. And if existing products jump to a higher quality quartile, it would decrease the frequencies of positive price change. And if an existing products fall to a lower quality quartile, it would increase both frequencies and size of price changes. And finally, we estimate the rate of quality growth in the US in the sample period, and we capture the deflation rate in CPU market in the US also. And thank you for your attention. If you have any comments or feedback about our works, please do not hesitate to contact me via the email that I put below this video.